Welcome back to Intro to Python. We are on class number 5 and we are on module 2, Understanding File Modes and File Objects. We'll jump back into the Jupyter Notebook and let's look at what we're looking at now. So, understanding file modes and objects, we just learned how to open files, how to read files, and how to write to files. But there's more to files than just reading and writing them. We can append to them. We can open up binary files and look at, objects like MP3s or graphics, and we can play around with these things inside Python as well. We also learned that best practices is using the with statement. That way we get proper closing of the file. Even if there's an error, if we use the with statement, it'll terminate that file and close that file handle so it doesn't get stuck by Python and the operating system frees up that file so we could delete or modify that file from another application. So the different file modes we've seen read, where we are able to open a file, go ahead and read the contents out of that file. We're able to write to files, add lines to them. But we also learned that as soon as we wrote to a file, it destroys everything in that file. So anything that was there previously gets wiped away and it says like it's a brand new file. The append mode allows us to append to the end of the file. So it opens the file, moves that pointer all the way, that little cursor all the way to the end of the file, and lets us start adding content to the file from the end of our file. So we'll take a look at append here in a second. Then we can also look at the X mode. This creates a new file, but if one already exists, it goes ahead and let us know that there's an error because the file already exists. This is similar to that write mode. It still only allows us to write to files, but it allows us to not stomp on a file and just delete it. Because we could have a 10 gig file, and as soon as we open it in write mode, it zeroes that file out and it's lost. So you'd have to use like some kind of file recovery tools to recover those files if you accidentally write a file that you didn't want to have the write mode on. The default mode is text. That's what we've been using. Without appending that T, it just assumes that we want it in text mode. If we put the B in place instead of T, then it opens a file in binary mode. That looks at the ones and zeros versus the actual ASCII value of a file, or UTF-8 actually to be more precise there. And then we have the plus sign, and this allows us to do both reading and writing. So if I'm in read mode and I add the plus, that allows me to also write. If I'm in write mode and I add the plus, it allows me to also read. And you'll see there's a big difference between R plus and W plus, because if I do a W plus, it's going to stomp that file, delete it, and then let me also read from it. But if I do read plus, it lets me read the file and then add to it or add lines to write to them, but it doesn't delete the entire contents of the file. All right, so let's go ahead and start it. We'll use our with open. Then we give it the path to the file that we're going to need access to. Again, we're in our day 5 notebook, and our files are right here that we're going to look at. So they're in the same directory. So I can use a relative path, which means all I really need is the file name. So if I can do my file.txt, and then I'm going to put it in our read mode. So I'm just going to do an R, and then I say as, give it a file name. We'll call it my_file like we did last module. And now I have a variable with the name myFile that I can simply read the contents of that file. So let's go ahead and do that now. Whatever we left in that file, I don't remember what we left in there, but we're going to go ahead and read the whole thing, and we're going to go ahead and write that out to the screen with a print statement. So I'm going to wrap the whole read line in our print statement and just show you the contents of the file. And I guess we left it with 4 lines of text and a new line. So you'll see that there's an extra line there because we appended new lines with it. Okay, so if I go to write mode, let's copy this. And we're going to go down here. And instead of read mode, we're going to go to write mode. And I'm going to create our lines. And this time it's going to be a list object. And I'm going to say test1 \n to give us a new line. Test2 \n. Test3 \n for the new line character, and then last test 4, but I forgot to put it in quotes, so I'm going to highlight it and rewrite it, test 4. Okay, and I wrote it in, didn't mean to run that. Where am I? Okay, I wrote it in write mode, so I cannot read from it, but I can write to it. So instead of read, we're going to use our WRI and then autocomplete, and see we want to write lines, and that takes a list object. So I'm going to pass into that function our list object. Remember, it starts with a square bracket, ends with a square bracket. That is a list object. They're comma separated values, and in this case I have 4 strings in there, and each string is terminated with a new line character. So as soon as I run this, it used to say line 1, 2, 3, 4. Now I'm going to go ahead and run it, and if I open up my file, you'll see it clobbered what was in there before, and now it says test 1, 2, 3, and 4. So write mode is going to clobber what's in there and then write the new contents. What if I want to do an append? So let's do the same thing now. We'll add a new line of code, and we're going to append to this with the A mode. And this, instead of 4, we're going to say 5, 6, 7, and 8. And I'm going to write lines with the append mode. So here's my file initially. Now if I double click it, it'll reload it. Maybe not, I gotta close it and then reopen it. Now it's been appended, and you'll notice that I didn't end that last one with a new line apparently. So that's why it put it on that same line of text. So I'll hit enter and I'll save that. Okay, so that's what the append does, and you'll notice I didn't close out line 4 with the new line, so it didn't add that in. So we'll add that in this one, and we'll also add it in here. So in the future when I run it, it'll work correctly. Okay, so we've seen read, we've seen write, we know append. Now let's look at X, the exclusive creation mode. Pop that open. Let's run our with block here. We'll say open, and we're going to give it a file. We'll call it myfile2.txt, and I want to open it in plus mode, right? I'm sorry, X mode, as my file. And we're going to go ahead and write some lines to it. So we're just going to write one word to it. We'll say my file dot write, and now I can just write a string. This is a test of the X mode for file creation. Okay, now my file, we're going to say my file 2.txt, which does exist. So I'm going to go ahead and run this, and you'll see we get file exists error. So this is an error telling us, hey, this file that we're trying to put in to write mode has contents in it, so we don't want to clobber it, so we're going to give you this error. So you can say, oh, not my file 2, let's put that in my file 3 that doesn't exist, and go ahead and run it. And that error goes away, and my file 3 gets created, and it gets created with the contents of the X file creation that we told it to write to that particular file. So X mode is nice. It's just like write mode. I can't actually read from this file. Like if I try to read, because I'm in X mode, I should get an error. We'll set the seek to the beginning of the file. So we're resetting the pointer to the beginning of the file. And then now I'm going to try to read out of that file. And I'll go ahead and print that to the screen. And this is going to give us an error because the first error we get is because file exists. So let's go ahead and fix that error. Delete that file. I wonder if I can just delete it. Are you sure I want to delete? Yes. Okay, so now if I run this code again, I'm going to get not a file exist error, but I'm going to get a type error. And what happens is the seek exceeded, oh, I need to give it a value of 0. Okay, got to delete file 3 again. So we've seen the File exists error. We see that I misused the seek method, and now we're going to get the error for the print. And that's unsupported operation error. So you've seen 3 different types of errors, and you'll see how we handle those in the next module. But for now, we just know that we cannot read once we've opened it in X mode. X mode only checks for file existence and then creates it if it doesn't exist, gives you an error if it does exist. We know that by default it opens into text mode, so putting XT is the same thing as just having it as X. So I could either append a T or a B after any one of these. So I could do A, T for text. All of these would be considered identical because it defaults to using that text mode. If I want to open something in binary mode, I would use the letter B. So binary is going to be data that's not obviously text-based. Like what we're doing here when I'm writing strings out, that's all text-based. But think about music, pictures, all these files that we see on the internet, graphics-wise, all that is considered binary. It's non-text, right? So YouTube videos, for example, binary data. So we could look at how we can do things in binary. So let's jump down here, create a new code block of code here, and we're going to say with open, and I've got to get some file. We'll call it some file. And then I want to open it in read mode. I got to put it in quotes first. Read binary as B file for binary file. And now let's go ahead and see how we can print, oops, not add, as. There we go. So let's go ahead and, since I'm in read mode, now I should be able to write out to the thing. So let's go ahead and run our print statement. We're going to print out B file dot read. That's going to give us the value, the contents of the binary file. And let's go ahead and, actually, let's just read the first 8 bytes. Of any binary file, there's a thing called the magic bytes. That's the beginning of a file. It tells you which file type you're dealing with. So we're just going to read the first 8 bytes of the file to see if we can figure out the file type. And I'm going to write it out as hex. So there's a nice hex function that we can call that will print something out as hex. So now the next thing we got to do is go get some binary file. So we'll go to our Google and type, I don't know, we'll get a Zoom background. Something that's a PNG file. This is a good one here, right? So I'll just right click, say save image as. We'll save it to our Python class, Python files. Just throw it in here as a binary file, and in a second we should see it show up in here. Maybe I didn't do it in the right folder. Let's go check. Where did my folder go? There it is. Yeah, so it is there. Oh, it just took a minute to show up in our Jupyter Notebook. So I can rename this file, and we'll just call it image, just to keep it simple. Image.png, and I'm going to open up image.png. And we're going to get the first 8 bytes, called the magic bytes, and we're going to print that out to the screen. And so you'll see I'll get 89, 50, 4E, 47. What exactly is, how do we know what file type that is? We have to go to Google and type in bytes for a PNG, and it tells us the PNG is 89, 50, 4E, 47. In fact, let's take a print screen of that. We'll just do just the PNG, stick that up to our screen as a, oops, I didn't do that right. I meant to do the pin. Now I got it pinned up to our screen. Come back to our file here, and you'll see 89, 0x89, then 50, got 50, then 4E, 47, 0D, 0A, 1A, 0A, 1A, 0A. There we go. So now we know for sure that this is a PNG file. So now if you're looking at some kind of intrusion detection system or intrusion prevention system, you cannot just rely on the extension of a file, but you can actually look for the magic bytes to say, is this file truly a zip file, or is this file truly a PNG? By looking at the magic bytes, that can tell us for sure how the operating system is going to treat the particular file. All right, so that's how we read something in binary. So we've got the last mode is this X, or I'm sorry, is the plus. The plus allows us to do both reading and writing. Scroll down here, we're going to create a new code section, and we'll do our famous with open. Give it a file name. Here we'll do my file again, in quotes, as a string .txt. We're going to open it as read, so we'll do our R. We're going to do it as a plus to make it sure that it's opening it in both modes. Then we're going to say as, and then give it a file name, colon sign. Now we have our indented code block with our with statement. And let's go ahead and see if I go ahead and read, let's do my file.read, which is going to read the entire contents of a file. And I'm going to go ahead and print that out to the screen. Then I'm going to, now that the pointer's at the end of my file, I'm going to say my file.write. And I'm going to write some message to the end of the file. We'll just say, this is a new write and there we go. So I'll write that after I've read the file. So R plus mode lets me read and then add also the write capability in at the same time. So we'll go ahead and run this. And you'll see I printed everything out, 1, 2, 3, 4, 5, 6, 7, 8. Then I appended at the end of the file, this is a new write statement. So if I open up my file, you'll see that it added that write to the end of our statement there. Okay. Now if I do it in reverse, so let's do W, do our plus sign. Then I'm going to go read the contents out, and then I'm going to append this is a W plus write statement after reading. And go ahead and run this. And you'll see what happens is, because it opened it in the W mode, it clobbers the file. I don't get an error for trying to read it, no big deal, but there's nothing to read because it's deleted everything. Then I went ahead and appended this to the beginning of our file because that's all that exists. And so now if I look at my file, you'll see that this is a W plus statement. So even though the plus statement gives you the opposite mode, so if you put an R plus, it gives you read and then write. Or if I do W plus, it gives me write plus read. It matters which order you do them in. And then also remember, we're defaulting to text mode, right? So that's another thing that you should be aware of, is that T is implied at the end because we're writing in text. All right, this is a quick recap. The different common operations that we do. We use the open to open a file. Best practice, again, is use that with statement because then it automatically closes the file when you're done. But not necessarily you have to use the open. We could do it without it. We could just say something like my file equals open, and we'll go ahead and use the text file right here called myfile.txt. And then I'm going to open it in. We'll do a append mode. So append gives me the ability to add to a file, but does not delete the contents of the file that already exists. So if I do that, I can also go ahead and write to it. We'll do a \n, so it does a new line. Then I'm going to say this is appended to the file, period. And I'll also close with a new line just because that's good best practice. Now, if I leave it there, I didn't use the with statement, so the file is going to be left in this open mode, right? It's going to be kind of just dangling out there. The operating system can't do anything with it because it's in this append mode held by Python. So when I run this code, let's close this first. Run this code, and you'll see that if I open my file, it has, this is a W plus write statement after reading, which is what we wrote up here, and it does not have this write statement here. Now, think about it for a minute. Why doesn't it have this write statement at the end of our file? Hopefully, if you paid attention to last module, you noticed that it wrote it to memory, but hasn't pushed that commit to the actual operating system file, so the actual hard drive. That's because we have to do a flush. So this is a lesson I learned very hard when my early years of programming. At my first college class, we had to write a C program where we just wrote a couple of statements to a file and saved the file. And for the life of me, I could not get it to actually save the contents of the file. I opened the file, wrote to it, and closed the file. That's because back in the early 2000s or late 90s, when I wrote in C, it didn't do the flush on a close. Python is generous, and it actually says, okay, I'm closing the file. I'm automatically going to assume I want to do a flush and then close the file. In the C language, you have to be very explicit and tell it to flush. So it took me quite a long time to figure that statement out because I didn't have ChatGPT and Google was in its infancy, so I couldn't even find the answer on like Stack Exchange. Didn't exist. But anyways, we're going to go ahead and flush the statement now. So just recall that we have this is the statement that existed in the file before. This is what we've appended to the file, held in memory, until we go ahead and hit this flush button. And now my file does show the appended line of text. And you'll also notice that there's a third line here. That's because we put a new line right here in our code. And so that's where you get that blank line 3. Okay, so we flushed it, but we still haven't closed it yet. So if I go to the operating system and I try to delete my file, you'll notice that I get that error because Python has it open. So let's go ahead and close the file as well. And now hopefully you see why using that with open syntax is so much more preferred, because it automatically closes the file once the block scope goes out of scope. So remember, block is whenever we've indented things 4 spaces, they're all part of that same block of code. As soon as you stop indenting 4 spaces, then it goes outside the scope of this with statement and automatically flushes the file and closes it for us. So it just does a lot of that cleanup for us if we use this one line of code. And also if we get any kind of errors, it goes ahead and closes the file for us as well. So that's a preferred syntax that we use. The only problem I don't like about it is it puts the variable assignment on the right-hand side, and we're so used to seeing variable assignments on the left-hand side like we do here, right? That's just the standard way that we assign variables, is we give a variable name, and then we do the assignment operator, and then we pass what we want to put into that variable on the right-hand side. So the with statement is definitely preferred. It's just you got to learn a little bit of that syntax magic that makes it work for you. All right, so that's a lot to take in. Please practice. Start writing some open statements with open, appending to files, closing files, flushing them, seeing how all that inner functionality works. Here's the different common modes: read, write, append, exclusive create. Default is text mode, but we could also do binary, and we could see magic bytes by the first 8 bytes of a file. And then we could also set it in both modes, read and write, or write and then read. Okay, so that's this module. And then next, we will look at exception and error handling, and how do we gracefully manage that. So take a quick break, and I'll see you in a few minutes to talk about error handling.